Hello everyone, welcome back to the Blue Team training series brought to you by Linode and Hackersploit. In this video we're going to be taking a look at incident response with FireEye Redline. More specifically, we're going to be exploring data collection or data and memory collection with Redline. So if you're not familiar with Redline, Redline is a tool developed by FireEye, and it's typically used by incident responders to essentially collect as much information as possible from a system that has been compromised, right? And you'll actually see why I've decided to cover, this particular tool, and you'll actually get an understanding of the various data collection features and why I personally prefer utilizing Redline whenever, I'm trying to essentially collect as much information as possible from a system that has been compromised. So in regards to what we'll be covering, we'll start off by getting an introduction to FireEye Redline. We'll then take a look at how to install Redline, and then we'll explore the Redline collectors and how to collect data and memory with Redline. So the prerequisites are going to be, pretty basic when it comes down to what you need to know. If you've gone through this part or this particular section of this series, and you've gone through the process of extracting or dumping memory on Linux with Lime, and you've gone through, data or memory forensics with volatility, then this should be fairly simple for you. So the objective here is to show you how to collect how to collect as much information as possible, as well as, create a memory dump of a Windows system. And you might be thinking to yourself, well, why is this important? Well, firstly, Windows systems are systems that are likely to be compromised, given the fact that, Microsoft or Windows has a majority of the market share when it comes down to, personal computers, or operating systems deployed in organizations, etc. So it's very important that as an incident responder, you have a good idea or understanding of how to collect all information or all relevant information from a system that has been compromised. So what is FireEye Redline? Redline is a free endpoint security tool developed for Windows, or really just for Windows systems, that was developed by FireEye and is typically used by incident responders to collect data from a compromised system. This forensic data is then analyzed to find signs of malicious activity through memory and file analysis and the development of a threat assessment profile. So when it comes down to analyzing memory dumps, you can pretty much utilize volatility, as it's much easier because you can also perform memory analysis, and you can also get an idea as to whether there are any indicators of compromise with FireEye Redline. It is also used not just for collection, but also for analysis. But that is something that we'll not be covering in this video, so we'll only be focusing on the actual data collection side of FireEye. So Redline is typically used to collect all running processes and drivers from memory, file system metadata, registry data, event logs, browser history, and much more. So you'll actually see this when we'll actually get started with Redline. So it essentially offers an all-in-one solution for incident responders to quickly and efficiently gather all required information and data from a compromised host. So that's really all you need to know, when it comes down to what Redline is and what it is used for. As I said, by this point, you should know what a memory dump is and why it's important when it comes down to, blue team operations, and why this is important for, incident responders and, forensic analysts. So as for the resources that you'll require, of course, I'll be linking these, to this video as a resource. But to download to actually download Redline, you can visit the link there. It is absolutely free to download. Now, there are two versions of Redline. We'll be utilizing version 2, which is the latest version. And then, of course, you have a really fantastic Redline user guide that FireEye have actually created for you. So this will pretty much give you all the information you need to know, from collection all the way into analysis, if that's something that you'd like to explore. However, in my opinion, I really like using volatility for my analysis, because that's the tool that I learned. However, with Redline, because it's a graphical user interface, it can be quite confusing to navigate around the actual menus and the various items, because the nomenclature is so different. So let's get started with the practical demonstration. I'm just going to switch over to my Windows 10 system, and we can take a look at a quick scenario and how we can collect data from a compromised Windows system. All right, so I'm back in the Windows system. This is the same Windows system that we used, for disk forensics. As you can see, we have Autopsy there and FTK, and I've already installed Redline 2. So if I open up the Redline directory here, let me just get rid of that there, as I was running a sample analysis session just to see, what I could do and couldn't do, because I'd used Redline back when it was in version 1. So quite a lot has changed. So if I open up, let me just move them out of that folder. But as I said, I have both versions. So you have a version 1.2 and version 2 here. To download them, just navigate to the link that I had in the slides, and you can see that it'll give you a description of the tool. So Redline is used for accelerated live response. So as it says right over here, is used for, essentially data collection and analysis. So with Redline, you can thoroughly audit and collect running processes and drivers from memory, file system metadata, registry data, event logs, network information, services, tasks, and web history, which is very important for an incident responder in essentially identifying what happened on the system. So, it allows you to analyze and view imported audit data, including the ability to filter results around a given time frame using Redline's timeline functionality with Time Wrinkle, which is, again, a third-party solution, and Time Crunch. You can streamline memory analysis with a proven workflow for analyzing malware based on relative priority. And of course, you can also perform indicators of compromise analysis supplied with a set of IOCs or indicators of compromise. The Redline portable agent is automatically configured to gather the data required to perform the IOC analysis and the IOC hit result review. So as you can see, it's very useful for, for incident responders, not just for collection, but also for analysis. But as I said, I'm more of a volatility guy. So to download it, just provide your details here. Unfortunately, you need to provide an email, but you don't need to verify your email or anything like that. So you can just download it. Once you click on download, you'll be taken to another page where you'll be able to download version 1.2 or version 2. So I downloaded both versions just to show you how they'll work. And this is version 2 right over here. So Redline version 2, it's a simple installer. Just double click on it and go through the installation wizard, and you should be good to go. So once that is done, I'm just going to open up Redline now. So I've essentially pinned it to my taskbar. So I'll just click on it there. Give it a couple of seconds. There we are. And welcome to Redline. So as you can see, Redline is broken down into two sections. You have collect data and analyze data. And of course, I've been analyzing a few memory dumps previously just to see, to actually test the feature set. But we're interested in collecting data. So with regards to, collecting data from a compromised Windows system, what are we looking for as incident responders? Well, we typically want to collect registry data, running processes, collect the memory images. So, take a memory dump, collect browser history, look for anything that looks suspicious in regards to executables and strings. So, stuff like that. We're going to be exploring the actual, process of creating a standard collector, which is what I recommend. And then you can also create a comprehensive collector. So let's get started firstly with the standard collector, right? So the standard collector essentially provides you with, if we click on it here, I'll just click on create a standard collector. So you can see that the collector can be created only for one of the following platforms. So let me explain what this means now. As I said, you can collect, your data and memory from a particular operating system. In my case, it really works well with Windows. If you're collecting or performing a memory dump on, on a Linux system, then I'll still recommend using Lime. That's just my own personal experience. So again, this is something that's very important. typically whenever you're going to be running your collection, you never want to essentially run Redline on the system you're actually collecting data from. Redline will create an actual collector script, as you can see here. So your collector package will be created and saved to the location you specify below. So what incident responders will typically do is they'll have a laptop or their own system with Redline on it. They'll configure the collector, and then they'll save that collector or the collector files within a flash drive or an external hard drive. They'll then connect that to the compromised system, and they will then run the following. It'll essentially provide you with a script to run. It's going to be a batch script. So on the Windows machine, you want to audit, run the Redline, run Redline audit.bat script, preferably on a removable medium, so a USB hard drive. The script will run the collector as you configured it and save the results to a folder called Sessions Analysis Session 1. Every time you run the script, a new analysis session folder will be created, right? So when the collector is finished, transfer the results back to your analysis machine and then double click analysis session.mans. Fairly simple extension there. And with that, you can then, open up that session within Redline on your analysis system. So it's fairly simple to understand. So we can click on Windows and we can say acquire memory image. So I'll click on that there. So checking this option will acquire an image of memory that can be used to accurately acquire process memory and drivers during analysis in Redline. So that's very important. So now you have to choose, or you have chosen to create your own standard collector. So the standard collector will collect the data necessary to perform a Redline analysis focused on memory-based audits. Note, this will not enable the options for the full range of data that Redline is capable of collecting, reducing the effectiveness of many indicators of compromise. So Redline typically recommends utilizing the following, the standard collector, because it's much faster and it's much better from the perspective of analysis. However, you can edit your script and it'll bring up this little dialog box here where you can specify what you want to collect. So in the context of memory, you can say, for process listing, you can you essentially collect handles, sections, imports, exports, and also detect injected sections, verify digital signatures, strings. That's quite helpful. For driver enumeration, you can also enable strings there. And also you have hook detection, which is very important. So moving on to disk, you can also enumerate files. So, I can click that there and I can say under disk enumeration, we can enumerate disks, but I'm just going to leave that unchecked because that'll take long. So you can say include active files, so raw only. We can pass the NTFS file index or the NT file system file index. There we are. Those are the buffers. Analyze entropy to essentially identify or detect encryption. Enumerate imports, yes. Include directories, get resources, that's really not necessary. Include files, and analyze file anomalies, that might be useful in your case. And then of course we have system. So this allows you to collect the machine and OS information, user accounts, analyze system restore points. So from this point, or from this, from here, you can actually see why I'm recommending Redline, because in terms of collection, you can really just customize what you want. So we can also perform registry enumeration, which is really useful. Event logs, which is very important for an incident responder. Network, we can perform port enumeration, ARP tables, routing tables, and then, browser history. So in this case, we'll just say port enumeration. Typically, yeah, the attacker might modify the routing tables if this is if this compromise was not really through malware, but through, exploitation. For browser history, we can say collect the cookies, let's see, file downloads, URL history, and we can also say indexed page content for Firefox. So let's try that as well. And also form history, if, that could also be useful. And then under other, you can also, check typically the services, with MD5, SHA-256. I'll leave those off. For persistence mechanisms, as I said, this is very important if you're trying to identify whether the attacker or the adversary has set up a system of persistence, whereby you can click on Analyze Entropy right over here. And you can then click on Analyze File Anomalies, get the version info, etc. In my case, I'm going to leave that unchecked. Once that is done, hit OK. And now you've essentially modified your own script here to collect the data that you want. So under the collector location, just specify where you want the batch script collector or the collector script to be saved. And this is the script that you will then transfer onto the system that is compromised, right? And you can just say browse. In my case, I'll just save it under Redline. There we are. So as I said, as it recommends here, you typically save it, on external storage medium. So hit OK. It's going to create the portable collector. There we are. So your collector package is created and saved to the location you specified. On the Windows machine you want to audit, run the Redline audit.bat script, preferably from the removable media. This will run the collector as you configured it and save the results in a folder as we know called session 1. And when the analysis or when the collection is finished, transfer the results back to your analysis machine, then double click the analysis session.mans file located inside the analysis session folder. Okay, so open the directory containing the portable package. As you can see, this is what you will need to transfer over to the actual system. So once that is transferred over to the actual system, you can then run the memory analyze audit script the run redline.audit batch script there. And that will begin the actual collection. So what we'll do is we'll just close up Redline because we don't need it now. The next step would be to analyze what you collected. So we'll get back to this menu in a second when we'll actually be exploring the comprehensive collector. So once that is done and we've transferred it to the actual compromised system, we're going to assume this system is the system that's compromised. What I'm going to do here is, let me just check my downloads folder just to make sure I don't have any large files. So I'll just get rid of memlabs there that we explored with volatility. And I'll just, empty the recycle bin. So you just need to run this. So I'll run this as administrator. There we are. It's going to open up a dialog box there. And it's going to begin the actual collection process based on the configuration specified within the memory audit script.xml file. So you can always edit this, on the compromised system if you want to make a few changes. So, you can modify your requirements here, whereby you can specify what data you want to collect and, whether you want to perform a memory dump as well. So based on the options, the collection options you specified, this is going to take a while, right? So do keep that in mind. Once it's done, it's going to save all the data under sessions, under analysis session 1, and you should have the actual Redline project file here that you can then open up with Redline for analysis. All right, so I'm just going to see whether, this is going to take a while because I selected a lot of options. As you can obviously tell, I actually specified that I wanted to collect quite a lot of data. So while this is running, we can open up Redline and take a look at the other collection options available. And that, of course, is the comprehensive collector, right? So this method configures the script to gather the most data from your host for further analysis. This you will usually take, up to an hour to actually complete. And, this will essentially, give you, all the data you will require to perform a complete analysis. So this is usually, if you're looking to perform an in-depth analysis and you want to understand really what's going on, then you can click on create a comprehensive collector. And, still within this, you can edit your script and, you can customize the options. As you can see, all the options here are going to be enabled. So we're already familiar with that. And again, all you need to do if you want to acquire a memory image is just check on that there. One thing I wanted to mention is you can also do this for Linux. The only thing with the script here, as it says right over here, on the Linux machine you want to audit, run Redline audit script and you'll be able to collect the data there. So again, that process is again very similar. What I wanted to highlight here is the actual IOC search collector. So this essentially is this right over here, or this particular collector is for Windows systems only, right? So this collector essentially collects data that matches with specific indicators of compromise that you created. And of course, I'll not go into the process of creating your own indicators of, the actual indicators of compromise yourself. But this is typically used when you want to run the data collection against, known IOCs that you have gathered or created. And of course, that is where threat intelligence comes into play. So we're not really going to be exploring that. However, one thing that I wanted to showcase here is the actual default collector. So the standard collector here. So you can see that this will configure a package with which will collect all of the data needed for Redline to score and assess a computer. So we can go for the defaults here. As you can see, these are the default options where it doesn't collect anything from disk, which really isn't that helpful because with volatility, that is already included. However, but for volatility, that's primarily for analysis. With Lime, for example, in the case of Linux, you essentially just collect the memory. However, in the case of using Redline for Linux, you can specify what you want to collect exactly. So if I click on Linux here, you can see for the memory, you get the process listing. For disk, you can pretty much include remote locations, include directories, include files. For the system, machine and OS information, port enumeration, and then of course you can collect the actual kernel modules, login history, shell history. So this is also very useful if you're trying to collect additional information as an incident responder from a compromised Linux system. So the process is essentially the same. Once you're done, just specify where you want to save your collector. But what I wanted to showcase in this case was how much faster this is when you're using the default configuration, where you essentially exempt or exclude disk collection, system collection, network collection, and the actual some of the other pieces of data that you can collect. So in this case, we can see if we can, collect user accounts, and we can also, check machine and OS information, which is enabled by default. So, we could also say collect the registry enumeration or, event logs, for example. So yeah, once we can just hit OK, and I'm just going to create another folder here for this particular one. So I'm just going to say browse, and we'll head over into desktop, and we'll just say, we can just call this test, for example. So you'll typically be saving this on a flash drive, and we can hit OK. And that is going to create the audit script. So we'll just close that up, close that there, and let's take a look. This one is still running. So, we can leave that running, but, we really don't need it now. That was just as an example. So as I said, once you are done, in this case, it didn't complete. So what we'll do is we'll just leave that as is. If we take a look at the test directory, we can then run this particular Redline audit batch script here. So I'll run that there. It'll automatically prompt you for administrative privileges, or to essentially, verify that, you essentially, require administrative privileges to run this. So it'll give you the UAC prompt. So I'll hit yes. And in this case, it should be much faster. So you can see that we'll give this one a couple of seconds, and then I'll show you how to essentially open that, that particular session file into Redline for analysis. So we'll give this a couple of seconds. So I'm just going to wait for this to complete. All right, so that collection method completed relatively quickly, as you can see from the timestamps. And if I click on sessions, you can see analysis session 1, and this is where you'll be provided with, as you can see here, analysis session 1.mans. Now in this case, it looks like it only performed an audit and we didn't perform a memory dump. So let me just open up that again, and let's see if we can include that. So you can see under analysis, you can essentially analyze from a saved memory file. So that could be a memory dump in raw format. You can open up previous analysis and of course your recent analysis here. So I'll just click on create a standard collector, make sure I acquire the memory image, in this case for Windows, and we can leave this as is. The only thing I'll add there is I want to collect user accounts and maybe event logs. And I'll also create this particular one, and I'll save it under, well, do we have everything under Redline? Let me just open this up here, and let me get rid of that particular collector, or, As you can see, that already collected quite a lot of information, but I stopped that collection as it was going to take a long time, probably around 30 minutes to an hour. So you want to be cognizant of time, but this is much faster than if you were to go through this process with other tools, or essentially go through it manually with individual tools that collect registry data. This just does it for you all in one go. So what we'll do here is if we go into our desktop, maybe we can just get rid of the test one here, and we can just save it in there, right? So we'll go for Windows, make sure we acquire the memory image, which will take slightly longer, but that's perfectly fine. Select the folder, we'll hit OK, and then we can run that particular batch script. So I'll close up Redline, and under test, we can run it as administrator to avoid the actual prompt later on. There we are. So that's going to collect it, and again, we'll give this a couple of minutes. All right, so once that is done, you can then transfer this back to your analysis system that has Redline installed. Click on Sessions, and if you take a look at X64 here, these are essentially the APIs used to collect the data. I just wanted to highlight that there. And, the same goes for X86 there. So we'll head over into Sessions, Analysis Session 1, and we'll click on that there. And give that a couple of seconds, and it's going to open the analysis session within Redline. So I'll cover the fundamentals of how the user interface works. So it's going to, import all of the data there that you actually collected, and then it'll provide it to you with a very simple and easy to understand interface. So on the home screen, you can see you'll have a sidebar to your left where you can click on, system information, processes, and, you can also view them via the hierarchy, the users, event logs, timeline tags, etc. You can also start your investigation. So you can specify whether you're reviewing a triage collection from HX, which is, again, essentially the FireEye endpoint threat prevention platform. You can also say I'm investigating a host on an external investigative lead. This is when you are starting with a piece of external information indicating that the host requires further examining. And then, of course, I'm reviewing web history data, and I want to search my data with a set of indicators of compromise. Those are not really applicable to us. So we'll click on system information because that'll display all the info that was gathered. So again, on your analysis system, you can see right over here, you get the machine name, the date, the time zone, the actual process identity, the type, the drives, so CND, one of which is a disk drive, the total physical memory, the available physical memory at the time of the capture, of course, the uptime, so 5 hours, and whether monitoring is enabled. In this case, it's disabled. You also get some BIOS information and the operating system information, like in this case the edition of Windows 10, or rather the version of Windows 10 and the build number, the patch level, the OS build, the system directory, when it was installed, the operating system architecture, the registered owner. That's not going to be displayed, but it would be displayed if there was a license. If this was licensed. I'm currently using the actual enterprise evaluation virtual machine, which comes with an 80-day license. And like we explored within our disk forensics video with autopsy, this could tell us, who owns that particular license. So that's the machine information. We then have processes here. So I'll click on that there. It'll take a couple of seconds. And in this case, you can see that, it will essentially provide you with a list of processes that were running on that system during the capture, or when you perform the capture. And you can essentially utilize regex and or search for specific strings. So for example, in this case, I could say, let's see if we can find the LSAS process. If I was looking for that, so there we are, lsas.exe, which is responsible for authenticating users. If I right click on it, I can copy with headers, or I can copy this. I can also apply tags and say, I want to follow up on this later. I can also escalate this, clean. I can mark it or tag it as clean. I can say I want to include this in the report. This could be a false positive. And in this case, I could just say, follow up there. And it's going to be tagged, so you can actually identify important processes here that could be useful. In this case, this is not really useful. I'll just give you an example there. So you can search or run your searches based on a particular field. So you can filter by process name, process ID, the path, the arguments, the username, etc. As well as one of the most important ones is going to be the actual security ID and the SID type, right? If we take a look at the actual the actual processes here that have been sorted based on the actual hierarchy, you can see they're sorted. So we have system, under system we have registry, and then of course we have CMD and connection host there, and this was the tool that was used to run the collection for Redline, and you get the idea. And of course you can search for strings. So we then have users. This will tell us the user accounts on the system. So we have the Windows administrator account, when they were last logged in, their user password. That's the password age, sorry. We haven't dumped the hashes yet, but there's the password age. We then have, so it essentially lists out all the other user accounts on the system. So, we can identify or confirm that this indeed is the administrator account there because of the SID. And, it gives us the description there. The important piece of information here during a compromise is to essentially identify whether this particular account has been disabled or has been enabled. So you'll typically see that the guest account should always be disabled and the default administrator account should always be disabled. If it is enabled, then something could have happened there. So you can also take a look at the password required column there. And you also have your event logs, which is very, very important in this case. It's going to take a while because there are tons of event logs. You can filter. In this case, we can look for security events, which you can either filter through or by the actual event ID, which is pretty much the best way to go about it. But we can essentially click on, if we take a look at the actual, let's see if we can identify that here. So let me just increase the actual size of this column. So that's the actual log itself. And then we have the type, which is either warning, information, error, etc. And the message here. And let's see if we can try and filter through this here. So ideally we can say filter based on the actual, let's see, let's use the type here. So I can say, we can say in this case, warning. And that will highlight, whatever you've searched for there. So, if I was to do, this is typically how you'd identify, important events by analyzing the event logs. And then, of course, you have the timeline feature, which essentially gives you a list of, pretty much whatever was done with the context of the actual timeline here. So you can see the user. In this case, this looks like it is, there's the timestamp there, which could be incorrect. So last login, and of course, this is set for the actual users themselves, which makes sense. But you can also filter based on, created files, when they were created, when they were modified, so on and so forth. And you can essentially learn what happened. So you can essentially say, I want to know when files were created, when they were modified. So, if the attacker modified any files, whether the file name changed. This is typically used in the case of ransomware to identify when, the system was infected, when the ransomware was executed, and when it encrypted all the files. So, as I said, you can use this for analysis as well. I just wanted to go over the analysis section just to show you how it works. But yeah, based on your collection, as I said, if you're doing a full, if you're utilizing the actual comprehensive collector, it's going to take a while, but that's really useful when you want to perform a full analysis on a particular session and, all the data that you collected. With that being said, that is going to conclude the practical demonstration side of this video. I'll probably be working on follow-up videos where we'll be taking a look at how to utilize Redline for analysis, as well as volatility and other tools to analyze different types of memory dumps from different operating systems. And we'll probably take a look at memory dumps, from systems that were actually compromised by malware. And we'll be doing the same for disk forensics, where, we'll have like a system that was infected with ransomware and, based on the actual forensic image that was taken off that disk. We can, sort of analyze it with autopsy to see what happened, and essentially get as much information as possible. So that is going to conclude the practical demonstration for this video. All right, so that concludes the Blue Team training series. Thank you very much for watching this series. If you've gone through part 1 and 2, you really should have improved your skill set, and you should have a good idea as to what Blue Team, or Blue Team operations consist of in terms of the actual roles and responsibilities. And as I said, this particular video series was an introductory series to Blue Team operations, and we were primarily focused on tooling and giving you an understanding of the concepts, concepts like forensics, intrusion detection, intrusion prevention, threat detection, security event monitoring, and of course we also covered quite a bit of forensics and incident response. But yes, as I said, thank you very much for completing this series. This is just the beginning. So if you watch this series to get an introduction to Blue Team operations, and you feel that this is a field that you like, then definitely this is just the beginning. And your journey is, you still have a long way to go, because there's still other aspects of of Blue Team operations, whether you're talking about traffic analysis, identifying malicious traffic, detecting intrusions, preventing intrusions, host-based intrusion detection and prevention, threat detection, security event monitoring, memory forensics, disk forensics, etc. So there's still a lot to learn, but if you've made it this far, congratulations. Once again, thank you very much for watching this series. If you found it helpful, please do share this series, as much as possible, because as I said, this series is absolutely free. And, as a resource, I think it's very helpful for anyone who is looking to get into that, into this particular field. With that being said, thank you again for watching, and hopefully I'll be seeing you in the next series.